Unlocking the secrets of thermodynamics. How a refrigerator keeps your food fresh and cool. What powers the magic that keeps your food fresh and your drinks icy cold? The answer lies in the fascinating science of thermodynamics. Get on board the science train as we uncover the mystery behind how a refrigerator works, exploring the principles of heat transfer and energy conservation that make it all possible. Get ready to be amazed by the brilliance of engineering and the power of thermodynamics in action. Hello, science lovers, and welcome to EQ Science, a channel dedicated to everything science, engineering, and technology. So if you're new to the channel, please subscribe and turn on notifications so you won't miss our latest uploads. Today we are diving into the world of thermodynamics and how a refrigerator works. Thermodynamics. The concept of thermodynamics can be defined in many ways, but is simply derived from two words: thermo, meaning heat, and dynamics, meaning work or to do work. So, the term thermodynamics can be said to be a branch of physics that deals with the relationship between heat, work, temperature, and energy in a physical system. It is concerned with the behavior of energy and its transformations, as well as the laws governing these processes. There are basically four laws of thermodynamics, which provide a basis for understanding and predicting the behavior of a wide range of physical and biological systems. These laws describe the behavior of energy and entropy, and the relationship of the other properties of a system, such as temperature, pressure, and volume. Thermodynamics is an important field of study with many practical applications, including power generation, refrigeration, which we are going to be focusing on today, air conditioning, and engine design. It plays a crucial role in many areas of science and technology, including mechanical and electrical engineering, materials science, and chemical engineering. Refrigerator. Refrigerators are one of the most commonly used home appliances, from keeping our food fresh for days to providing us with the leisure of cold drinks. The use of the refrigerator in our daily life is so common that we hardly ever wonder how it works to keep our items cool and fresh. A refrigerator helps to lower the temperature of our foods and hence kills bacteria, which in turn prevents the food from spoiling. Before the invention of electric refrigerators, fortunes were made shipping large blocks of ice to achieve cold temperature for storage of food and beverages. Today, thanks to refrigerators, we do not have to go through such struggles to save our food from spoiling. The process that refrigerators use today is based on the work of the 19th century American inventors Oliver Evans and Jacob Perkins. In 1805, Evans came up with the vapor compression refrigeration cycle, which we now employ to make refrigerators, but he was never able to build a refrigerator. In the 1830s, Perkins made the first refrigeration system based on Evans' ideas. Although Perkins' system wasn't a commercial success, it was the first step towards the modern refrigerators that we use today. Before we try to understand how this refrigeration cycle works, let's first understand what components of a refrigerator are involved in the cooling process. Components involved in a refrigerator cooling process. These are basically components that helps in the cooling process of a refrigerator. They are refrigerant, compressor, condenser, thermostatic expansion valve or TEV, evaporator, and receiver. Refrigerant. Refrigerant is usually a gas or a liquid that facilitates the conversion of thermal energy into mechanical energy by undergoing a phase change. In refrigerators, the refrigerant fluid can also be addressed as a coolant that flows through the refrigerator to maintain the temperature inside it. The most commonly used refrigerant fluids have extremely low boiling points. Example: hydrochlorofluorocarbon chemicals, or HCFCs, that are generically referred to as freons. Refrigerant is a critical component in a refrigerator that helps regulate the temperature inside the appliance. It is a substance that is used to transfer heat from the inside of the refrigerator to the outside environment, thus keeping the temperature inside the fridge low and stable. The refrigerant is stored inside the refrigerant coil and is constantly circulating through the system. A critical aspect of the refrigerant in a refrigerator is its pressure. The pressure of a refrigerant determines how efficiently the refrigerant circulates through the system and affects the temperature inside the fridge. A low refrigerant pressure will cause the fridge to be too warm, while a high pressure can cause the refrigerant to overheat and damage the system. Compressor. The compressor is considered the heart of the refrigeration system. In technical terms, a compressor is a device that increases the pressure of a gas by reducing its volume. In refrigerators, the compressor mechanically increases the temperature of the refrigerant fluid by forcing it to move through a low-volume pipe. It is a vital component in a refrigerator system. It is responsible for compressing refrigerant gas from a low pressure and temperature to a high pressure and temperature. This high-pressure, high-temperature refrigerant is then passed through the condenser, where it releases its heat and condenses into high-pressure liquid. The compressor is typically driven by an electric motor, and it functions by creating a pressure differential between the high-pressure side and the low-pressure side of the refrigeration system. This pressure difference is what drives the refrigerant through the system, ensuring that heat is transferred from the interior of the refrigerator to the exterior. In addition to compressing the refrigerant, the compressor also acts as a pump, circulating the refrigerant through the system. This circulation is necessary to maintain a consistent temperature within the refrigerator, as well as to ensure that the refrigerant is properly condensed and evaporated. It is important to maintain the compressor in good condition, as a faulty compressor can result in a number of problems, including reduced efficiency, increased energy consumption, and increased wear and tear on other parts of the refrigeration system. Regular maintenance and inspection of the compressor can help to ensure that it continues to function properly and efficiently. The compressor is usually located at the lower part of the backside of the refrigerator. Condenser. A condenser, or condensing coils, is a mesh of pipes that one can find on the backside of the refrigerator. The main function of the condenser is to remove the inner heat of the refrigerator, just like a radiator. It is called a condenser because the removal of heat is achieved by the condensation of the refrigerant fluid from vapor to liquid state inside the condensing coils. Heat is given off as the temperature drops to the condensation temperature. A condenser is a crucial component in a refrigerator. It helps to transfer heat to the surrounding air, which is why it is often located at the back or bottom of the refrigerator. The condenser is typically made of metal coils that are filled with refrigerant. When the refrigerant absorbs heat from inside the refrigerator, it passes through the condenser coils, where a fan blows air over the coils to help dissipate the heat. The refrigerant then cools down and returns to the refrigeration system, where it repeats the cycle of absorbing heat from the refrigerator and releasing it to the surrounding air. In order to function properly, the condenser must be clean and free of any obstructions, such as dust or debris. This is because any buildup on the condenser can impede the flow of air over the coils, which can reduce the efficiency of the refrigerator and cause it to work harder to maintain the desired temperature inside. It is therefore important to periodically clean the condenser to ensure that it is functioning optimally. Thermostatic expansion valve. Popularly called TEV, a thermostatic expansion valve is a type of valve used in air conditioning and refrigeration systems to control the flow of refrigerant into the evaporator. The TEV senses the temperature of the refrigerant leaving the evaporator and adjusts the flow rate based on the cooling demand of the system. The TEV consists of a valve body, a bulb filled with temperature-sensitive liquid, and a capillary tube connecting the bulb to the valve. As the refrigerant temperature in the evaporator changes, the temperature-sensitive liquid in the bulb expands or contracts, which in turn opens or closes the valve to control the flow of refrigerant into the evaporator. TEVs play a critical role in maintaining the proper refrigerant charge and temperature in a refrigeration system, and ensure that the system operates efficiently and effectively. Evaporator. This is the part of the refrigeration system that does the cooling inside the refrigerator. Its function is to absorb heat into the refrigeration system from the inside, which then radiates out of the system through the condenser. The evaporation coils are present inside the refrigerator where we put our food items. The refrigerant fluid is let into these coils by the thermostatic expansion valve. It is responsible for moving heat from the refrigerated space, thereby lowering the temperature and maintaining the desired temperature inside the refrigerator. The evaporator works in conjunction with the compressor and the condenser, which are also part of the refrigeration system. The refrigerant, usually a type of coolant, is compressed and pumped into the evaporator by the compressor. As the refrigerant evaporates inside the evaporator, it absorbs heat from the air inside the refrigerated space and cools it down. The refrigerant then returns to its liquid form as it releases the absorbed heat to the condenser, where it is cooled and compressed back into a high-pressure, high-temperature vapor that is pumped back into the evaporator. This cycle continues until the desired temperature inside the refrigerator is achieved and maintained. Receiver. In a refrigerator, a receiver, or liquid receiver as it's commonly known, is a component that is part of the refrigeration system and is responsible for receiving and holding refrigerant. It is a small metal container with an inlet and an outlet that allows refrigerant to flow into and out of the system. The receiver serves as a storage tank for the refrigerant, allowing the compressor to regulate the refrigerant flow to the rest of the system as needed. The receiver also helps to separate any oil that may be present in the refrigerant from the rest of the system, preventing contamination and ensuring that the refrigeration system operates efficiently. Some receivers also have a dryer, which helps to remove any moisture from the refrigerant, further improving the performance of the refrigeration system. The receiver has inlet and outlet connections and a threaded port for the installation of an overpressure safety relief device. The main purpose of a receiver is to act as a buffer for the refrigerant fluid during the refrigeration cycle. Working principle. Having looked at the various components that aids the cooling process of a refrigerator, let's look at the working principle of a refrigerator. The basic principle behind the working of a refrigerator is the second law of thermodynamics. More specifically, Clausius' statement of the second law of thermodynamics, which states, "Heat can never pass from a colder to a warmer body without some other change, connected herewith, occurring at the same time." This statement can be understood as follows. To transfer heat from a region with lower temperature to a region with higher temperature, mechanical work must be done on the system. This is evident in a refrigerator as heat flows from a cold environment, inside of the refrigerator, to a hot environment, outside of the refrigerator, but only when forced by an external agent, that is, the refrigeration system. In other words, refrigeration is just reverse operation of a heat engine. A heat engine takes heat from a hot body, converts a part of it into mechanical work, and rejects the rest to a colder environment. On the contrary, a refrigerator employs mechanical work to transfer heat from a region with a lower temperature to a region with a higher temperature. This periodic delivery of heat is known as the refrigeration cycle or the vapor compression refrigeration cycle. Let's discuss how this process is carried out inside a refrigerator. Refrigeration cycle. A refrigerator works by circulating a refrigerant through a closed system of coils and pipes to transfer heat from the inside of a fridge to the outside. This is known as the refrigeration cycle, and it consists of 4 main steps. Step 1. The refrigerant, typically a gas, is drawn into the compressor at low pressure. The compressor then pressurizes the refrigerant and causes it to become hot and high pressure. Step 2. The hot, high-pressure refrigerant is then passed through the condenser coils, which are located on the outside of the fridge. As the refrigerant passes through the coils, heat is released to the outside air, causing the refrigerant to condense into a high-pressure liquid. Step 3. The high-pressure liquid refrigerant then flows through an expansion valve, which reduces the pressure and causes the refrigerant to rapidly expand and cool. Step 4. The low-pressure cool refrigerant then enters the evaporator coils, which are located inside the fridge. As the refrigerant evaporates, it absorbs heat from the inside of the fridge, causing the temperature inside the fridge to drop. The refrigerant then returns to the compressor, and the cycle starts all over again. The refrigeration cycle continues to repeat, maintaining the temperature inside the fridge at a constant cool level that is ideal for preserving food and beverages. The temperature inside a fridge is typically between 0.5 and 4.5 degrees Celsius or 33 and 40 degrees Fahrenheit, which slows down the growth of bacteria and other microorganisms that can cause food to spoil. This allows us to store our food items for an extended period of time, keeping them fresh and safe to eat. There we have it, guys. Next time you open your refrigerator, you'll know the mystery behind its working and how it's made your food and drinks fresh and cool. Thanks for watching. I hope you learned something from today's video. Please remember to subscribe and turn on notifications, and I'll see you in the next video.